Hello, everyone. Good morning, good afternoon, or good evening, depending on where you call home. My name's Kyle Benaz. I'm the Director of Marketing at Netreo. I'm also joined by James Mancini, Netreo co-founder and solution architect. Today, we'll be discussing the 3 keys to automating IT management, where we'll focus on leveraging automation and artificial intelligence for better IT outcomes. Before we get started, I just want to cover a few quick housekeeping items. All attendees are in listen-only mode, but we like to keep our webinars interactive. If you do have questions throughout the webinar, please feel free to submit them using the questions section of the GoToWebinar control panel, and we'll try and answer those as they come in. We've also allotted some time at the end of the webinar for live Q&A, so don't be afraid to bring your toughest questions to James. With that, let's get started. James, take it away.
Thanks, Kyle. So some of the most common challenges that we hear about from our customers are things that might be very familiar to some of you. So things in IT have always changed rapidly, but it's only picking up speed. The explosion of DevOps, cloud-centric architectures, and on-demand dynamic provisioning is making it increasingly difficult to keep monitoring and management tools in sync with the environment. And this leads to the second issue. Management and individual teams lack visibility into the whole environment. So most existing management tools are slow to adapt to the rapid changes and deployments that are becoming routine in most organizations. And we find this is often because visibility suffers when it's difficult and labor intensive to manage. If a manual process is required to add monitoring onto new systems, there's just no way it can stay up to date. Often, this lack of an up-to-date view across the organization leads teams to implement their own point solutions. And the more tools you're dealing with, the more likely they are to contradict each other, to say nothing of the increased admin and training burdens and the communication issues that this can cause. Many large customers have told us about the challenges caused when, one failure causes multiple alerts from different products to different teams who then argue over what the actual problem is, and that drags out resolution times. Fortunately, most of these challenges can be solved the same way. Automation is the answer. We need a way to keep up with rapid and dynamically changing environments while maintaining visibility, avoiding blind spots, and keeping up SLAs, and all while not creating additional admin overhead that nobody has time for. So automation is something we've been working with at Netreo for many years now, and we define automation maturity in 4 primary stages. And those stages are discovery, monitoring, response, and artificial intelligence. Over time, and the last 20 years of development, our platform has evolved to do all of these. So let's kind of look at each one, and you can start to see where your organization might be today and what the next steps might be. So the first stage of automation is discovery automation. And this technology has been around in its most basic form basically forever. We've probably all used tools that do a ping sweep or a port scan to find devices on the network. And that technology still makes sense in a lot of environments, but it's really not the whole answer anymore. Today, auto discovery has changed a lot because there's a lot of things you can't scan reliably. Isolated virtual systems, DMZs, cloud-hosted systems, and microservices, just to name a few. So modern systems leverage the power of API integrations to make automated discovery faster, more reliable, and much more complete without creating network traffic problems. For example, we leverage these APIs to learn directly from systems like ServiceNow CMDB or vCenter, Azure, AWS, as well as things like SD-WAN orchestrators. And we also provide inbound API calls to allow users to link our system with existing workflows like Ansible, or to create custom integrations easily without relying on expensive consultants. Now, the next stage from there is monitoring automation. And this is where adding new devices to monitoring and getting them correctly configured no longer requires manual intervention. For many organizations that we speak to, they haven't even really gotten this far yet. Now, there are a few reasons for that, but one of the most common is that a lot of monitoring platforms are surprisingly underdeveloped in this area, and in-house development resources are scarce and expensive when they exist at all. So to really reach this stage effectively, the management platform has to be able to identify new systems, not just at the OS level, but also to detect things like what services or applications are running on them in order to make the right decisions about what exactly needs to be monitored on a given system. So for example, if I bring up a SQL server as a virtual machine, that should enable monitoring of the OS, the virtualization stack, and the SQL application itself. It should also set appropriate event log monitors and who to alert when it has a problem. And that could be different depending on whether it's a SQL problem or an OS problem, as well as what kind of performance metrics and statistics that we want to watch. It also has to include putting in the right categories, sites, and application groupings to drive reporting and dashboards so that newly deployed systems always show up in the right places and nothing falls through the cracks. This stage is really about reducing the administrative time required to keep everything operational and to make sure you're not having to struggle with blind spots or spending too much time on care and feeding of a monitoring platform, or worst case, many different platforms. Now, the third stage is response automation, and this is designed to enable our platform to take independent action to remediate a problem before the NOC or the engineers have to do anything. So this might be, restarting servers or, restarting services as they detect a problem so it can happen faster than humans can react. Now, in order to effectively automate response, we have to allow different actions based on things like time of day or day of week, in case we want a different response during business hours. It should also allow for things like dependencies, like taking a different action if there's other servers running the same application that are having a problem at the same time. And of course, there should be the ability to do this across platforms, whether it's routers or Windows or Linux or switches or even cloud hosting providers. And this is going to require different methods of interaction with all of those different devices. Some of those are going to require API calls, others might need PowerShell or SSH, and you need to have the flexibility to kind of interact with all of those. Now, this kind of automation can be a big step, and some organizations are going to insist on operator intervention, at least at first, to approve the action before it's taken. We call this the click to reboot button. And this is a good idea for drastic actions, but it also lets organizations get comfortable with the process and validate their configuration before they fully automate the response as actions. We can do it either way. Now, stage 4 is where we're talking about artificial intelligence systems. So while there's obviously a lot of different definitions around what exactly constitutes artificial intelligence, here we're using the term to define systems that can expand the context and template provided by human intelligence into large-scale data analysis. So it has to be adaptive and learn and improve over time. Applying this kind of technology to your operations is typically referred to as AIOps. So for example, a system might look at alerts coming out of the monitoring platform and detect that it's a certain kind of alarm is happening too frequently and might be a false alarm, and then suppress those alarms or modify the settings to stop the alarms from happening. Or it might notice a correlation between specific log messages and later application failures and restart some services automatically to remediate those issues, since that worked last time the application failure occurred. Ideally, an AI-enabled management system will make these connections and potentially take actions based on learning your environment, as well as things like best practices and scenarios encountered across other customers. So it's critical to be able to decide which actions to allow to happen completely automatically and which ones should require operator intervention, especially at first. The only real potential downside of this approach is that it can drive very high resource requirements, often what is well beyond the practical limits of what you can provision in your own data center. And so this generally means you need to have some sort of cloud hosted resources helping out in order to sort through all the data that's coming into the system, and that's going to drive a connectivity dependency to get full functionality out of it. So the first key to automating IT management is to make sure that we're taking full advantage of discovery and monitoring automation. And obviously the first step here is to make sure that we're using auto discovery tools and API integrations to make sure that new devices are being brought into monitoring as they're provisioned rather than relying on a manual checklist. And once those devices are identified, we need to make sure we're getting full monitoring automation. So we need to make sure that it's correct and complete, and that we're identifying all the different applications or services that we need to monitor on those systems. If those configurations can be based on cascading templates, that makes this a lot easier, as you can have multiple templates applying to the device or application as appropriate. So let me talk a little bit about how this process works. So when we talk about getting discovery working, what we really mean is that our approach is going to take multiple parallel paths to make sure nothing gets missed. So we have configurable subnet scanning so that we can quickly identify new systems as they're provisioned. But as I said earlier, this method has a lot of limitations in a modern IT architecture. So we want to also make sure we're leveraging other discovery methods that can provide faster or more complete information, like leveraging the API connectivity to different vendor platforms. So, if I bring up new Meraki edge routers as I bring them online, I need them to be added into monitoring without having to manually go do that. Or instantly start monitoring new cloud containers or serverless databases or virtual machines as those are provisioned in the cloud. And as I mentioned before, we also provide inbound APIs for system provisioning. So if you're using automation tools like Ansible or Chef or Jenkins or even Puppet, you can push things into the platform and link it into your deployment process to make it part of that issue. So by using all of these different methods simultaneously, we can make sure that we've got a complete picture of the environment and nothing gets missed, even if things are changing rapidly or dynamically, and even if somebody didn't follow the process checklist as precisely as they should have. So to get this to the next stage, we then need to take that discovered device data and make sure it's getting fully provisioned. So it's useful if a new system gets detected and we can tell if it's up or down, but it falls short of full visibility if we're not also watching all of the critical applications and services, or if we're not automatically sending notifications to the right teams when something doesn't work right. So our approach to this is using a feature we call auto configuration. And auto configuration comes with a set of rules that you can use to get started, and you can easily customize or create to fit your environment or even download from the cloud. You can use these to set device attributes like categories, site, and business workflows based on any device criteria, including things like what processes are running, what ports are open, what the device is named, or even things like SNMP location, to make sure that there's no manual provisioning process to get the device in all the right reports and to get the right settings applied to them. And then these need to be automatically applied to devices as they're discovered, regardless of what method is used to add them or what platform they're running on. We also allow you to reapply those rules automatically or on demand. So if you want to make sure everything stays configured according to the rules that you've created, you can enforce that. Now, to close the loop on that process, once all those attributes are applied, we dynamically apply all of the relevant templates to those devices. So this makes sure that all the settings that we need applied to the devices get put on there without any operator intervention. So kind of the earlier example I set is that when a SQL server comes online, we not only want the basic Windows Server settings, but we also want SQL specific application checks. We want, SQL specific log monitoring. We want SQL specific alerting to make sure that all of the SQL specific settings are applied completely and correctly to the devices as well. But by applying them in layers using cascading templates, we don't have to make another copy of the Windows template and add all the SQL stuff to it. We can just layer those settings on top. And what that really means is that even in a complex environment where we have a lot of different applications and different combinations of applications running on systems, we can maintain a very small number of templates so that you can keep them up to date. Because if I have 25 copies of my Windows template, some with SQL, one with Exchange, one with IIS, one with my own application running on it, and then combinations of some or all of those. If I want to change something that's fundamental to the Windows monitoring, I've got now 25 places to go do it, and it's really hard to remain consistent. So by doing it in layers, we make it much easier to do that kind of automation and configuration. These can also define things like authentication parameters, escalation, and even the active response, so event-driven response, to automatically remediate problems. So those can all be applied through the templates, and it's designed to be flexible enough to meet the needs of large global enterprise customers, but still be easy enough to use that small IT departments can do it without a lot of training or having any dedicated personnel. So let me just kind of show you how all this works together in the platform that we've built, what we call our automation architecture. And it looks complicated at first, but it's really pretty simple. So it starts with discovery, which is driven by connecting with APIs, CMDB systems, cloud providers, SD-WAN providers to learn new devices as they're set up there. It also includes scanning, of course, so we can learn about connected network segments, find new devices to monitor, find new subnets to scan, and map out the network that way. But it also includes those open APIs. So if we have DevOps tools or process integration, we can make that happen really easily. Together, that represents discovery automation, and new devices that are added through that discovery process get passed off to the auto config process, which uses those rules to automatically put devices in all the correct categories, applications, sites, and business workflows, and use those criteria to include in automated reports and dashboards. And it also then uses those to define which templates I want to have apply to the device. So we can apply multiple templates this way, and we can make sure all the correct settings are on all the devices and not have to maintain large numbers of templates. It all then drives the settings for the device, including authentication, alerting, anomaly detection, even configuration management rules. And all of those get applied to the device automatically, which configure the monitoring engine, which drives the dashboards and custom views, as well as sending all the alerts via email, SMS, mobile application push, webhooks, and as well as things like ticketing integrations. So now that we've automated the process of getting all those new monitoring provisioned for devices and applications as we bring them up in the environment, the next level of automation includes automating response. And this allows us to take the appropriate actions in the event of a failure or even an anomaly by automatically executing commands on certain devices or sending API calls to cloud providers, for example. Now, you can link in CLI commands like SSH or PowerShell or use APIs so that your monitoring system can restart ports, deploy additional containers, retest applications, or even dump real-time diagnostics when an incident is detected. Now, some people are uncomfortable with that automatic execution, so we allow you to control those commands manually through operator intervention if you prefer. That way, if you want to have the click to reboot button directly in the web interface of the monitoring system and limit access to just the administrators, we give you a really easy way to do that. So one of our customers set the system up, for example, to automatically reboot the system if it fails after hours, but during working hours, it only notifies the NOC, and then they can make the decision as to how best to remediate that problem while they're available. However, one thing to keep in mind is that when we're automating response, maintenance windows become absolutely critical. Otherwise, a scheduled software upgrade is not going to go like we expect because the monitoring system is going to start taking actions in the background. And nothing's more frustrating than pausing an application service so that I can do a deployment and then having the server suddenly reboot. We make it really easy to create those maintenance windows though, because you can do them via the web interface from the mobile app or even via an API call, so we can directly link it into our change control system if we like. Now, incident management is a key part of automating incident response. And this is the process that we use that allows our platform to understand complex or advanced dependencies with the goal of reaching zero false alarms. So they allow you to easily override configured actions in order to send customized alerts or suppress a redundant alarm or automate specific responses, like running a shell command, for example, or calling an API to provision additional resources. But that process takes 30 to 45 days. I'm sorry, one example of this is a customer who used a lot of remote retail locations, and they had very limited bandwidth. So when they detected that the site was getting congested, they'd schedule a circuit upgrade that takes 30 to 45 days to implement. So they made a rule that intercepted any bandwidth or latency alarms for those sites and then sent a message to the branch manager letting them know that they knew about the problem and the upgrade had already been ordered. And by doing that, they managed to reduce those calls into their NOC by over 80%. So we also allow you to configure dependencies based on grouping. So for example, if you're seeing a bandwidth issue on a remote location, you could automatically correlate any latency alerts for devices at that location with that bandwidth problem so they don't generate separate notifications. Or if you've got a cluster of systems, for example, you can take different actions depending on the state of other cluster members at the time. Now, one way to really take advantage of automated response is to make sure that we're removing false alarms as well as finding hidden issues. So detecting unusual behavior is a key way to make that work. And the way we do that is through something called anomaly detection. So you can use anomaly detection to find changes in application behavior or unusual behavior based on time of day or day of week. So the idea is that you can apply this to any of the different metrics or telemetry that you're monitoring within the platform. So CPU, memory use, running processes, even the number of log messages coming in. So for example, if an application server suddenly goes from 10 login failures an hour to 1,000, then maybe that last software update didn't go quite as smoothly as we thought, but at least now we know exactly where to start troubleshooting. So the system is designed to automatically generate a baseline behavior model using the large volume of historical data we retain, which is for most metrics 3 years. And then we'll automatically adapt the baseline as the environment dynamically changes and evolves. So it learns over time, what's normal for a particular process or a particular system, so it can detect when that isn't normal. You can look at changes based on time of day. You can look at based on day of week or even hour by hour. And the idea is that this helps you to find unexpected impacts. So one example is we had a customer who got notified that the number of transactions on their database had dropped below what was normal for 9 a.m. on a Wednesday morning. And they were able to quickly trace that to a UI change that was routing orders to a dev system instead of the production one. So that sort of anomaly would never trigger a static threshold, for example, but was quickly identified and opened a trouble ticket for them before they had an impact to their sales or operations. So if we look at how that fits into the automation architecture that we talked about before, um, this is all should be pretty familiar to you because we just looked at this a second ago. So we talked about how the auto config engine drives attributes that assign templates, and those control the parameters used by the monitoring engine, but they also drive active response actions. So this is event-driven automation that automates your response to incidents. And by taking load off of your NOC or operators, they can respond more effectively to outages or resolve problems faster. So we can automate the process of deploying well-established resolutions and use that to drive a reduction in MTTR. Or you can even just let the operators take the final action, but providing them a quick and easy way to do that, to be able to execute remote commands or call APIs to restart virtual servers, or even launch new containers, or just grab diagnostics to hunt down an intermittent problem. So even after automating the process of finding new things to monitor, and then automating the process of getting all that monitoring set up, and then also automating the response to those incidents, you still have the task of regularly reviewing what's regularly going on in the environment. So we need to tune to reduce false alarms. We need to optimize our monitoring configuration and watch for excessive alerting that might be coming out of the system, or things that we're monitoring that we might just not care about enough to do anything about. So in order to get to this next stage of automation maturity, we need to leverage the power of artificial intelligence and machine learning to help us keep the environment running and monitored. So the first phase of this is an automatic administration tool we call AI Autopilot, where we're using AI tools to evaluate how the systems are configured, what performance metrics and thresholds we're using, and analyzing how those are working in the environment. So effectively, it's looking at the reports for us to find common misconfigurations, or integration problems, or finding systems, for example, where the credentials were changed, but the monitoring system wasn't updated. So finding the correct ones and automatically applying them so we don't miss any performance data or alerts is something that the system can do for us. It can also do things like look at what other customers are doing and develop best practice recommendations to point out things that might be configured unusually in your environment, or where a more optimized way to monitor something exists. And then it can provide recommendations where an administrator can apply them with a click, or even apply those changes automatically if you want it to. And this whole process is designed to be fully automated. So it's just a matter of switching it on and then deciding if you want to ask for approval before making changes. So we've actually had customers deploy this in their environment and reduce their alert volume by 77% in the first month, and cut their admin time by almost a third. So let me show you how this works. So essentially, when activated, the AI Autopilot examines the configuration of all the different system elements, and it looks for things that it can optimize. So it's looking for things that are misconfigured or not integrated properly, or maybe just not set to best practices. And then it can provide reports and recommendations based on that data. It can also then automatically apply those changes to all of the configurations within the platform. And this effectively reduces the training and administration load, as well as ensures that the tool can stay optimally configured for your environment without a large time investment. The recommendations and best practices that the module uses are continually updated from the cloud. So as our customers find new and more efficient ways to do things, or the industry standards change, the platform can continually stay up to date. Now, our approach to AIOps mirrors our approach to all IT management. The first and most important thing is that the technology be usable. Systems that require weeks of specialized training to take full advantage of aren't really a good or effective solution. It needs to offer value to every different IT team, and it needs to do it quickly and easily. But it also needs to be practical. AI and machine learning are only as good as the data that they have to analyze. And we've spent the last 20 years collecting baseline data and experience in thousands of customer environments, allowing us to build solutions based on a strong foundation of practical and pragmatic customer use cases. Finally, it needs to be integrated. Our approach is to take a domain-centric view of the environment. So since we already have a deep understanding of the type and context of all the data that we're collecting, it gives us a huge head start in interpreting and processing that data to make meaningful conclusions and take meaningful, effective actions based on it. That means you don't need to implement multiple overlay products to try and get a benefit, and you skip all of the integration work and extra administration that those kind of approaches can cause.
All right, thanks, James. Appreciate that was a great webinar there. So we have a great audience today, and it looks like a lot of you are non-customers, so which is great to see. So for those who don't know us, Netreo is a full stack IT management and monitoring company leveraging AIOps, as James just showed. So we monitor more than 15 million devices and assets per day across just about every industry imaginable. Company was founded in 2000. We have several patents and global awards. We actually were just awarded a high performer by G2 Crowd. We're also network computing's monitoring product of the year for the last 4 years straight. And we've been on the Inc. 5000 list for the past 4 years as well. So with that, James, let's open it up for questions. So I don't know if we had many questions come throughout the webinar. While we wait for those to come in and answer them, I'm going to open up a poll here. So please let us know how we can help you further. So I do actually see a question. So is there a way to try Netreo for free, or do you have a free trial? Yes, we do. Just give me a second here, and I will actually enter that link in the chat box. And we're happy to follow up with you as well. So please feel free to fill out that poll. Let's see, any other questions? So I'm not seeing anything through. James, is there anything else that you'd like to add?
No, I think that's good for today. Well, thanks
Okay.
everybody for your time. I appreciate you taking a few minutes out of your day to join us and hear a little bit about what we're doing, and look forward to working with you in the future.
Thanks, everyone. Take care.